So another thing in IB physics is circuit analysis. Really cool topic because we use circuits all the time. And the four most important things in circuits to know are voltage, current, resistance, and power. And then from that we can just figure out the energy and stuff and how much your electric bill is going to cost. But as long as you can figure out the voltage, current, energy, or resistance, and power of the circuit or different parts of the circuit, then you'll be able to do well in this section. Now there's three different rules. Let's take the three golden rules of circuits. The first rule is the loop rule, which says that the voltage in any loop is used up. So that means you can't have like 10 volts in one loop and then 20 volts in a different loop. They have to get used up to the same amount of voltage. Once it gets back to the battery, all that voltage has to get used up. The second rule, the current or junction rule, says that whatever current goes into a certain spot of the circuit, that same amount of current has to leave that circuit. So if, for example, if you have this circuit, for example, I can't have like 2 amps here and then 2 amps here and then 1 amp here, because 2 plus 1 is 3 and that doesn't equal 2. So the 2 amps has to split up evenly, or some amount goes here, some amount here. So maybe it's like 1.5 and 0.5, maybe it's 1 and 1, whatever, but the total amount has to equal 2, or whatever it is, right? And the last one, rule number 3, is Ohm's law. Oh my God. This law is so important because it's such an easy equation, V equals IR. Using that equation, you can figure out one of the things. And then if you want to do V equals IV, I always say that for the last step. Figure out the power that the circuit uses, because power is very important because it tells you how bright the light bulb is going to be or how much energy it's going to use over time, within a certain amount of time. So let's do 2 examples here. I have 2 examples. We're going to apply these 3 laws. I like to make tables to keep things organized, little verb tables. So the way we look at it is look at each section at a time. So let's look at this first circuit. I know that the voltage of the battery is 10 volts. This is a symbol for battery. These are resistors. I have a 10 ohm resistor and a 20 ohm resistor. So right away I can fill in the resistance of each resistor. Let's do that in black. So I know the 10 ohm resistor is going to equal user resistance of 10 ohms. The 20 ohm resistor is going to be 20 ohms. Look at that. That's kind of nice. All right, what else do we know? Well, let's go rule by rule. The loop rule. The loop rule says that the voltage in any loop is going to be used up. So I can actually draw 2 loops here. There's this loop, meaning that electricity is going to leave the battery, or the positive side is going to go around this loop. By the time it gets to the other side of the battery, all of that voltage has to get used up. So every single thing in that path, the total voltage has to get used up. Well, there's 10 volts here. It goes around the circuit. This thing right here is the only thing that can use voltage. It's the only thing it ran into that uses voltage. So right there I know that that has to use 10 volts. So the resistor uses 10 volts because that's the only thing in that path. I could draw another path, a separate path around the outside, and it gets back to the battery. And look at that. Every single thing in this red path has to use up 10 volts. So I go around this path. Look at that. That 20 ohm resistor is the only thing in that path, so it has to use 10 volts. So both of these use 10 volts. Look at that. As long as I know 2 pieces of information in the column, I can fill in the other ones using this law, Ohm's law. So if I want to find the current, I just do I equals V over R. I just rearrange that equation. I'll write that down. I equals V over R. So 10 divided by 10, it's 1 amp. 10 divided by 20, it's 0.5 amps. Then, to figure out the power, I'll just use I times V. Well, I times V is 1 times 10, that's 10 watts. 0.5 times 10, that's going to be 5 watts. And then if I want to figure out the totals for this, well, the total power is just going to be 10 plus 5, which is 15. The total resistance, this is kind of tricky. When the resistances are in parallel, you can't just add them up. What you have to do is you have to do the 1 over R deal. 1 over R total is equal to 1 over R1, which is 1 over 10, plus 1 over 20. Now, if you don't like doing that method, you can come back to it using one of these laws, because I know that the current, let's look at the current. The current in has to equal the current out. So the current in this one is 1 amp. The current in this one is going to equal 0.5 amps. So this is 1 amp, this is 0.5 amps. They meet back up at the battery. So what's the current on the battery? Well, it has to give out 1 amp and 0.5 amps. So the total current has to be 1.5 amps. Oh, sweet. Now that I know P and I can figure out the voltage. So just use that. 15 equals 1.5 times 10 ends up being 10. And I knew the total voltage. All you have to do to find the total voltage is just add up the voltage of all the batteries. There it is. There's the voltage. All right, then I can use vehicles IR to figure out this. So it would just be V is 10, I is 1.5, so R ends up being 6.7. I could have gotten that two ways. I could use that equation, or solve for R total in this equation and got 6.7 as well. Let's look at a different type of circuit. Same rules apply. Same rules apply. Let's go step by step. Go in this table, so we know that the total voltage is 10. Let's say I did this. That's how it's tricky. I did 5 volts here, and then I did 5 volts here. They're both facing the same direction, so that's the first thing I look for. They're both facing the same direction, then I can add them up. If they're facing opposite directions, then you subtract them. But you can add them up, so 10 volts is a total. I didn't change that. I want to make it the same. All right. Resistances are given, 10 and 20. So I can put those in. This is 10, this is 20. All right. What else do I know? Well, I know that the loop rule, the voltage in any loop is used up. I only have one loop here. There's only one possible loop that this can make. It's this loop. Right? I know that by the time it gets here, to this side of the battery, 10 volts has to be used up. So whatever voltage this is, plus whatever voltage this is, has to add up to 10 volts. Okay? Do I know the resistance? Yes, I do. The resistance has to be added up because the resistance in a series circuit like this, you just add them up. So 10 plus 20 is 30. Okay? Now that I know that the voltage is 10 and the resistance is 30, I can use good old V equals IR. All right? So we have 10 equals I times 30. So I would equal 10 over 30, or 0.333. Now, I can look at this current rule. I'm just jumping around here, but like I said, as long as you follow these rules, you can think, does this rule work? Does this rule work? Does that rule work? Yes, it always works. You just have to figure out a pattern or path to try to take. All right. So the current. Well, if there's 0.3 amps going to this one, 0.33 amps going to this one, there's actually 0.33 amps going to the battery, and the total current is measuring the current in the battery. So this is 0.33. 0.33. Likewise, there's 0.33 amps going to the whole thing. It doesn't split up. Well, now that I have pieces of information, I have enough information to fill this out. 0.33 times 10, this is I times R, is 3.3. 0.33 times 20 is 6.6. 3.3 times 6.6 is 9.9, which is rounded, so it rounds to 10. So it does work. The loop rule works because the voltage of this plus the voltage of this has to add to the total voltage of 10. And then once again, I can figure out my power, just use P equals IV. So I'll just do this times this to get my power, that times that to get my power, that times that to get my power, etc. And there's lots of ways to check your work for these. So hopefully that makes sense.